Hello, everybody. Welcome back from the coffee break. We're here still with Josh ZapWizard, and I believe he's going to show us a little bit more about his fantastic Pip Boy prop from Fallout.
When Fallout 4 got announced, even before it was released, they showed the Pip Boy in their launch videos. That's when I started this project.
And when was Fallout 4 released? I never even
At least
played,
5 years ago now, because they've been working on this for 5
ago.
years.
And the Pip Boy, it's basically like a gauntlet that you slide your hand into, and it's got like a PDA on it. Is that right?
Yep.
Okay.
So in game, it's basically your smartwatch. It's just imagine a smartwatch designed in the 1950s. It's nuclear powered, and that's why it's so big. When I saw, I've already had played the previous Fallouts, and there was a Pip Boys in those Fallouts. They weren't as practical to me as this one. I also didn't have the CAD skills back then, so I decided when this got announced, I started designing my own. And my goal has been, as one reason it's taking so long, this thing is going to be 100% functional. If it does it in the game, this thing is going to do it pretty much. So this is my mechanical mock-up. It doesn't have any electronics inside yet, necessarily. But like, for example, having the holotapes mechanism eject, which it does in-game. Having the holotapes, which are small little kind of cassettes that are in-game. This one actually is electronic. So it's got a little moving door like a floppy disk has. And inside there's a light. And this one's just a mock-up prop that just lights up. The real one is actually going to transmit infrared data via IR codes.
Oh, neat.
So
where does it transmit between what?
Between this and the Pip Boy, between the holotape and the Pip Boy, so that you know which holotape got loaded in. The actual holotape isn't going to contain much data. You might be able to put like a log file or an audio clip or something like that and have that get transmitted. But instead, it's going to be more that you load it and the screen is going to switch over to whichever holotape you loaded, and that'll be preloaded in memory.
Wow.
I've done a lot with this in the game. There's a kind of a docking connection, electrical connection, that is on a ratcheting mechanism, which kind of pulls out. I've got that partially working. Yeah, so it actually clicks, and there's an actual ratchet in there and retracting mechanism. I have a helical twisting piece that deploys a USB connection and hides it so that it's game accurate when it's hidden.
Wow. It's amazing.
Game accurate,
and then
but it also works in real life.
Yeah, it's game accurate feeling. The buttons are clicky. There's ball detents that are all snapping into place.
The ratcheting you were talking about.
Yep, exactly. The radio knob on the front is geared in such a way that when you turn the knob, it actually moves the radio dial slowly. It has a rad gauge on here with an actual analog gauge meter. And then inside is a electronic dosimeter. It's going to have a microphone, a speaker. It's got a nav switch.
Like an actual dosimeter?
Actual dosimeter. I do have a video of that, and that's another secondary Fallout project. So this is another this is the mechanical mock-up. This is my Fallout scientist dosimeter. So this is a pocket-sized in game. The characters wearing this. The scientist characters are all wearing this in their pocket on their lab coat as a dosimeter. So I've designed this one. It's initially was using an Arduino code running on an MSP 430, and I actually had almost most of that working, and I have it all prototyped. And ran into some roadblocks. I really didn't like the way you had to load the code onto the MSP 430. It worked great in prototype. In production, it was a nightmare as far as like trying to actually get it loaded. So I'm thinking about redoing this in CircuitPython. But in either case, this even though it's pocket sized, being 3 inches wide and or 4 inches wide, 2 inches tall, and only an inch thick, it's actually one of the smallest Geiger counters that are out there. But inside this little metal tube is a real Geiger tube, a pretty large one that's actually fairly sensitive. And I found a very small circuit called the Pi G, like as in Pi Guy. that somebody released that's just based on based on a 555 timer being a voltage amplifier to get to 500 volts to drive the Geiger tube.
500 volts. Good gravy.
It's 500 volts at an extremely tiny amperage.
Yep.
In fact, you got to put a mega ohm resistor on it to read it with a voltmeter, or you just collapse the signal anyways.
And that's what you have there is actually running at 500 volts.
The prototype is over on my electronics bench, but this one is hollow right now. But this has a real mechanical switch, and then the display will be a full rail gauge, exact same motor that I'm using on the Pip Boy, which is this little tiny dime-sized, what's called an air core motor. Most people aren't familiar with them. They're really hard to drive. I had to learn how to get it to work like 3 or 4 times in using different drivers. What they are is 2 horizontally opposed magnetic coils surrounding one magnet. And so if you just think about it, you charge one coil, the magnet's going to align to that one coil. You charge the other coil, it's going to align to the other coil. And now to get anywhere from 0 to 360 degrees, you either charge one coil positive or one coil negative. And you have to do the sine, cosine, which I had to kind of go back and relearn all this, in order to set the actual angle. But once you actually get the code for that, it works pretty well. In fact, this is what's running on my... I'll switch over my cameras here.
So would you say it's a form of a stepper motor?
It's similar. You drive it kind of like a stepper motor. You use a dual H-bridge driver. So this is my Radiation King radio, which is another Fallout prop. This is what I'm working on currently. And so this actually has the air core motor inside. So this works very much like an analog dial. I initially was going to use a stepper motor for this project, but when I put a stepper motor in here and actually tested it, when you run a stepper motor really slow, it is very much in steps. That's why it's called the stepper motor. So I went and then bought a 360 turn stepper motor that said it had 800 steps, thinking, okay, it's going to be smoother. When you're running it really slow, like you might be tuning a dial, it doesn't work that way. Where an air core motor is analog. Really? It's being driven like an analog motor, and once you get the code working, the only issues you run into is there's a little bit of funniness when you get near the coordinates. That was the thing I had to learn, and you need a proper dual H-bridge driver that has separate polarity control from speed control. That was the key to getting that to work. And now it works perfectly smooth, and the only steppingness I'm actually getting in there is a little bit of jitteriness. I'm running the code, and I got to optimize it, that I'm actually sampling using an ultrasonic 80 kilohertz microphone on a custom circuit board I made. This is a PDM ultrasonic microphone, meaning it's digital, and it's sampling that 512 times at 80 kilohertz, and it's actually detecting a 1960s ultrasonic remote control.
Now, those are the remote controls that when you hit the button, that's why we used to call them clickers.
Yes. So this has a nice, really satisfying clicking sound. It's really quite loud in person. And then inside, it's purely mechanical. Inside there is an actual metal rod that is vibrating.
And I know not everybody could see this. That's actually an old remote control for a television.
Yeah, so this is a Zenith Space Command remote. Yep, Zenith Space Command remote. This is an authentic one from eBay. I also got a much dirtier one that I scavenged some parts from. And as far as I know, I'm the first person to get one of those working with a modern microcontroller where I actually detect the actual buttons. There's another guy on YouTube when I was doing my research to try to see if anybody had done this or get this working, and trying to figure out how to read an ultrasonic signal. It's actually, there's the ultrasonic rangefinders that every hobby kit has are extremely common, and that's the first thing I tried. But they all have cutoff frequencies that are really narrow so that they work great as a rangefinder. It wasn't until I finally searched DigiKey and actually started looking at the microphones and found this really cool, I can't remember the name of the brand, but it's the SPH0641LU4H1. This is the only one I found that is actually, it's basically 100 hertz to 80 kilohertz of sensitivity. And it's actually, it has has gain at the ultrasonic frequency ranges. Then I had to learn how to do, and that's something I guess I should say with my projects. Most of my projects is me trying to learn something. All the Pip Boy, all the Radiation King is me learning Python. The ultrasonic remote was me learning how to do FFTs. Something I'd never done before, fast Fourier transform. Maybe I said that wrong, but...
No, you've got it.
So that's something I had to learn how they actually work, how they process the data out of them. I'm amazed it's running on a Pi Pico. So both the Pip Boy and the Radiation King use a Raspberry Pi Zero as the OS core and running the audio and the heavy stuff, and a Pi Pico running all the analog GPIO, and in this case, it's actually sampling the ultrasonic remote. I'm kind of pushing the edge of the speed on it. The amazing part is microcontrollers are so cheap that for $5 now I can put another one in, and that one can do the ultrasonic completely separate from the rest, and they can all talk to each other and all run at full speed, and that's probably what I'll end up doing. Very cool. So all of your Fallout things can basically talk to each other ultrasonically. Is that kind of the end goal of all of this? No, this was more me making the radio from the this 1950s style radio. The radio actually works in such a way it won't come across on audio over here very well. It actually tunes like a real radio. So I wrote code that makes this feel live. It's playing a playlist of radio stations, and it actually distributes them across the dial. So if you have 10, you put 10 radio stations in a folder, that folder becomes a band, kind of like AM, FM bands. And you can switch bands, and then you'll have 10 new radio stations. You switch into the next band, you might have 15 new radio stations. And then when you tune across these stations, there's fuzz in the middle. When you get near a station, the volume comes up and the distortion goes away, and it plays in the clear when you get on the dial. And then you go back off and it starts fading again. But the cool part is that I parse all the radio stations, all the song lengths, I cache all that data, and when you're playing it and tune off of the station, technically it stopped playing, but it's virtually playing in the background by just keeping track of the time. When did it stop? What is the current time? And then when you jump back in, it's, okay, it's been 10 minutes since you were on that radio station. It jumps 10 minutes down the line in that radio station. It does it so fast, it feels completely seamless. And you can literally fling the dial and get all the little pops and blips you have on an old school radio where it comes in and drops out. And then you can jump back and it'll be on that same spot. And so I have this thing loaded now with I'm probably up to like 50 different radio stations where I'm grabbing every public domain list of here's 500 jazz songs. Here's, from 1930s to the 1950s and things like that, and dumping those into folders. And then exploring it the same way you did in old school radio, where I can jump around and listen to an audio drama or listen to I even got old school radio broadcasts, like war broadcasts and things, so it feels like you tuned into a time machine. It's actually really quite fun to play with. Well, that's awesome. It seems like you made a lot of really interesting props. I guess one other thing we wanted to ask you about. Now, I guess you make accessories for Leatherman tools. Is that right? Yeah. So that's my I'd call that my side hustle.